All right, area of region between two curves. If y equal to f of x and y equal to g of x, with f of x greater than g of x are two functions continuous on the interval from a through b, then the area of the region R between the two curves bounded by x equal to a and x equal to b. So that is this one. See, here we have y equal to f of x. Here is the other function y equal to g of x. And I want to find this area between these two curves from x equal to a up to x equal to b. So this area is the definite integral from a through b, is the definite integral from a through b of the upper function minus the lower function, f of x minus the g of x integrated with respect to x. We are integrating with respect to x because if I try to draw a vertical rectangle of width delta x, you can draw a vertical rectangle of width delta x over there. So this vertical rectangle of width delta x, if we draw it like this, you can move this all the way to the left or all the way to the right, and it's always between these two functions. So because it is always between these two functions, it's a single area, and it is the integration from x equal to a to x equal to b. And because it is vertical, you can see that as we are sliding from left to right, it is parallel to the x-axis. So that is integration with respect to x. Example, evaluate the area enclosed by the curves y equal to, or f of x equal to half x plus 1 and g of x equal to absolute value of x. So first we need to sketch the graph of these two functions. So here we have the graph of y equal to the absolute value of x, which can be written as y equal to x on the positive side and y equal to negative x on the negative side. And this function, f of x equal to half x plus 1, is this one here. We need to find the area enclosed by that. So we need to find the area of this triangular region. We know this point, this is 0, 0. We can find these 2 points using calculator. So if I use calculator to find this first point of intersection over here, that will be negative 2 over 3 comma 2 over 3. We can use calculator to find that point. Similarly, this point over here, it will be 2 comma 2. That will be 2 comma 2. Now, if I try to integrate with respect to x, what I can do is I can draw a vertical rectangle like this of width delta x, and I can try moving this all the way to the right. If I try to move it all the way to the right, you can see that it is between this function, which is y equal to half x plus 1, and the lower function is y equal to x. And then if I try to move it from here, from the right end towards the left up to here, up to y-axis, it is between that function half x plus 1 and y equal to x. But after that, when I cross on this side to the left, when I'm over here, you can see that in this case, the vertical rectangle is between this function and a new function here. That is the function y equal to negative x. So on the left of the y-axis, it is between the function y equal to half x plus 1 and y equal to negative x. Whereas on the right of the y-axis, it is between y equal to half x plus 1 and y equal to x. That means there are two regions over there, two separate regions. So if I want to find the area enclosed, then we can obtain that by finding the value of two integrals. The first one is from here, that is from x equal to negative 2 over 3 up to 0. And the second is from 0 up to x equal to 2. Now let's set up the integral to evaluate this area. So area A is equal to the sum of two definite integrals. The first one is from x equal to negative 2 over 3 up to 0. Negative 2 over 3 up to 0. And for this reason, the upper function is half x plus 1. half x plus 1 minus the lower function. Here the lower function is y equal to negative x. We are subtracting a negative x, which is same as adding x. Then plus the second integral is from 0 up to 2. It is from 0 up to 2. Upper function is half x plus 1, half x plus 1. Then minus the lower function is this one. We are subtracting x. So we set up the integral to find that area. Before I evaluate the integral, I'm going to combine the like terms in each of these integrals. The first one, we have negative 2 over 3 up to 0. Half x plus x, that is 3 over 2x plus 1, integrating with respect to x. The second one is from 0 up to 2. Here we have a 1. And then half x minus x is minus half x. We combine the like term because half plus 1 will be 3 over 2x and half minus 1 will be half, so negative half. So that is negative half x. Now we can evaluate the integrals. Integration of 3 over 2x with respect to x, we increase the power over here, so it will be x squared over 2. So it will be 3x squared over 2, and here is also 2. It will be 3x squared over 4. 3x squared over 4 plus integration of 1 with respect to x is 1x because derivative of x is 1. And this must be evaluated between negative 2 over 3 and 0. Plus, over here when I integrate 1 with respect to x, that is x. Then minus, when I integrate this x, it will be x squared over 2, there is a half. So it will be x squared over 4. X squared over 4. This should be evaluated between 0 and 2. Now using the fundamental theorem, first we have to plug in 0 here. So you can clearly see if I plug in 0, that will be 0 squared times 3 over 4 plus 0. This will be 0. And then minus, I need to plug in 2 over 3. Here is 3 over 4 multiplied 2. We have x squared. So 2 over 3 squared will be 4 over 9. 4 over 9. And if I plug in 2 over 3 for this x, negative 2 over 3 for this x, it will be negative 2 over 3. Then plus the second one, I'm going to plug in 2 there. So that will be 2 minus 2 squared is 4. 4 over 4 will be 1. Then minus, if I plug in 0, that will be 0 minus 0 squared over 4. That's also 0. Which is same as, if we simplify that, let me simplify here at the side. So the area will be, area A is equal to, the first quantity that I'm getting here is, I'm subtracting this. So you can clearly see we have a 0 and then minus, so I'm subtracting that. That is minus. And then here 4 and 4 cancel. It is same as 3 over 9 or 1/3. Negative 1/3. And then negative and negative will be positive 2/3. And here plus we have 2 minus 1, that is 1. Which is equal to 2/3 minus 1/3 is 1/3 plus 1, which is equal to 4/3. So that is the area enclosed by these two functions f of x and g of x. Example, find the area of the shaded region R shown in the graph below. So here we have a function y equal to x plus 5. Here is the other function which is y equal to x cubed. And we want to find the area enclosed by these functions. Find the area of the centered region enclosed by these two functions and also the x-axis. So we want that area R. So what I can try is I can try to integrate with respect to x. If I want to integrate with respect to x, what I do is I draw the vertical rectangle like this of width delta x and try to move from the left end of the area to the right end. So if I move from here up to y-axis, it is between this function y equal to x plus 5 and x-axis. But after that, when I go to this side, over here, if I draw that rectangle over there, you can see that now it is between the upper function y equal to x plus 5 and the lower function y equal to x cubed. That means if I want to find the area of this rectangle, then I have to set up two integrals. So let me write that down. Area A is equal to, the first one is the definite integral from here, that is from -5 up to 0. From -5 up to 0. Over here, the upper function is x plus 5. The lower function is this one, the x-axis, which is y equal to 0. So I don't have to subtract anything because subtracting 0 will be the same, x plus 5 with respect to x, plus now the second integral. The second integral is from here, that is from x equal to 0 up to this one. So I need this x value. So if I want to find this x value, I can use my calculator to get that value. So if I use calculator to obtain that value, it will be 1.9 comma 6.9. So the x value will be 1.9. So I'm integrating from 0 up to 1.9. 0 up to 1.9. And over here, the upper function is x plus 5 minus the lower function is this one, which is x cubed with respect to x. So we set up the integral to find the value of the area represented by the shaded region over here. Now we are going to evaluate this integral. This should be equal to the first one. Integration of x with respect to x is x squared over 2 by using the power rule. Integration of 5 with respect to x is 5x, evaluated between -5 and 0. Then plus integration of x is x squared over 2. Integration of 5 with respect to x is 5x. Then minus integration of x cubed is x to the 4 over 4, evaluated between 0 and 1.9. If you plug in 0 here, that will be 0 squared over 2 plus 5 times 0, that will be 0. And then minus, if we plug in -5, -5 squared is 25 divided by 2. If I plug in -5 here, 5 times -5 is -25. Then plus, for the second one, I have to plug in 1.9 first, subtract and plug in 0. So if I plug in 1.9, that will be 1.9 squared over 2 plus 5 times 1.9 minus 1.9 raised to 4 over 4. Then minus, if you plug in 0 to all of these, that will be 0. Because it involves a lot of decimals here, we can simplify this using calculator to get the final result. So we got the result 20.547. So that is the area of the region R shown here in this figure. Example, find the area of the shaded region R shown in the graph given. So here we have one function in blue, that is y equal to 2. Here is the other function in blue, which is y equal to natural log x. And here is the reason r in which is stated here. We have to find the area of that. So if I want to integrate with respect to x and find the area, what I have to do is I need to draw a vertical rectangle like this of small width delta x, and I need to slide from left to right. If I go all the way to the right on this side, it is always between the function y equal to 2 and the function y equal to x. This is true up to this point over here. If I come up to here, up to that point, from here, from the extreme right to this point, it is between y equal to 2 and y equal to log x. But after that, over here, it will be between y equal to 2 and the x-axis, which is y equal to 0. That means in order to find this area, I need two separate integrals. So this is how we can set up the integral. Area A is equal to, the first integral is from here, from 0 up to this point. This is the intersection of the log function with x-axis. So this point must be 1, 0, because log 1 is 0. That point is 1, 0. So the first integral is from 0 up to 1. Integration from 0 up to 1. The upper function here is y equal to 2. Lower function is 0, so I'm subtracting 0 with respect to x. So I'm integrating 2 with respect to x, plus the second integral is from here, from x equal to 1 up to this point. We need to know what is that. So your y value is always 2. You can see here the y value is always 2. So if I want to find that point of intersection, I can equate these two. Log x equal to 2, that's what I can do. Log x equal to 2. So meaning of that is x equal to e to the 2. So I have to integrate up to e to the 2. So this point, let me write that point. That point is e to the 2 and 2. Because in order to find this point of intersection, this is the point where these two functions are equal. That is log 2 equal to 2. That means x equal to e to the 2. So I have to integrate from 1 up to e raised to 2. And here the upper function is y equal to 2 minus the lower function is natural log x. And I'm integrating with respect to x. Now let's simplify the integral. The first integral, integration of 2 with respect to x, is 2x evaluated between 0 and 1, plus the second integral, integration of 2 with respect to x, is 2x, then minus integration of natural log x. Integration of natural log x is x log x minus c. So I'm subtracting it, so it will be negative x natural log x minus x, so it will be plus x in this case because I'm subtracting that. And this must be evaluated between 1 and e squared. Now, if you use the fundamental theorem of calculus, we plug in upper limit, subtract and plug in lower limit. So if I plug in 1, 1 times 2 is 2, minus plug in lower limit, so that will be 2 times 0 is 0, then plus, for the second integral, we are plugging in e squared, so it will be 2 times e squared, 2 times e squared, minus for x, I'm plugging in e squared times natural log of e squared plus e squared, then minus and plug in the lower limit 1. So it will be 2 times 1, which is 2, minus 1 times natural log 1 plus 1, because I'm plugging in 1 for everything. First part, that is equal to 2. 2 minus 0 is 2. then plus, here we have 2e squared, 2e squared, and over here we have natural log of e squared. So whenever we have the exponent like this, we can bring that in front. So it will be 2e squared, 2e squared, and we are left with natural log of e, which is 1. So it will just be e squared, 2e squared, plus e squared, then minus, over here, natural log 1 is 0. So this is 0. And here we have 2 plus 1, 3. That is 3. So we get over here e squared, 2e squared, 2e squared cancel. Here is e squared remaining. And then over here we have 2 minus 3. 2 minus 3 is 1. So we get e squared minus 1. And if we simplify this using calculator, e squared minus 1 is 6.389. So that is the value of the area shown here. Example, compute the area of the region enclosed by f of x equal to 2 over 1 plus x squared and g of x equal to 2x and the y-axis. So if we sketch the graph, this one, the green one is the graph of the function y equal to 2 over 1 plus x squared. This one in purple is the graph of the function y equal to 2x. And we need to find the area enclosed by these two functions and y-axis. So the area shown here in yellow is the region, or that is the area we want to calculate. If I want to integrate with respect to x, I need to draw a vertical rectangle like this, which you can slide from left to right, and it remains always between these two functions. The lower limit for that area is x equal to 0. The upper limit is obtained by finding this intersection point from the calculator. So from calculator, this intersection point is 0.7, 1.4. That means the lower limit for the area is x equal to 0, and the upper limit is 0.7. So now we can set up the integral. Area A is equal to the integration from 0 up to 0.7 of the upper function minus the lower function. Upper function is 2 over 1 plus x squared minus the lower function is 2x. I'm integrating with respect to x. 2 is a constant. I can take that out. And integration of 1 over 1 plus x squared is tangent inverse x. Then minus integration of 2x is x squared. Because derivative of x squared is 2x, so integration of 2x will be x squared. And we need to evaluate this between 0 and 0.7. This must be evaluated between 0 and 0.7. Now if I plug in 0.7, the upper limit will be 2 tangent inverse 0.7 minus 0.7 squared. Then we subtract and plug in lower limit. So minus 2 tangent inverse 0 minus 0 squared. Everything in the second bracket will be 0 because tangent inverse 0 is 0. Now in the first one, we can simplify that using calculator, and our calculator must be in radian. So the area of the region is 0.731.